All right. So let's say you have these. Let's say you have these 3 points. And so you know this. The model of this is something where it gradually increases up to some maximum point, and then it starts to decrease again. Okay, that refers to a quadratic model, and you'll use quadratic regression for this. And you can, the more points you have, the more accurate it's going to be in modeling this for you. But let's say if this is the information, so if you are testing a car, and these are the 3 points that you test, you find what is the gas mileage at each of these. What this is going to allow you to do is you can find the maximum speed. Hold on. All right, so what if we want to find the ideal speed for fuel economy based on this? And so, again, you don't know that 55 is the maximum for this particular car, but let's say these are the 3 speeds that you test, and those are the 3 fuel efficiency readings that you get. You can use your calculator to find the quadratic equation that models this, and then how would you find the ideal speed, which gives you the best fuel efficiency? What do you think you would find on this graph? What's going to give you the best value of y, the highest point of y? Any ideas? What's the highest point of this graph called? The vertex. So if you find the vertex, then you can find what is the ideal speed for fuel economy in this car. So let's talk about how you would do that. And we have these 3 points. If we think of it in a chart, the x-coordinate of 25 corresponds with a y-coordinate of 30. X-coordinate of 55 corresponds with a y-coordinate of 38. And an x-coordinate of 70 corresponds with a y-coordinate of 31. And so if we look at this and we enter this information, do you guys remember doing our data matrix editor stuff back in like chapter 1.4 and then later maybe in chapter 4 as well? And when you enter your data matrix, you go to your application, data matrix editor, go ahead and use the current one. If you're on the computer or the calculator on the computer, you may have to click on new, or it may ask you to rename it. If you rename it, you can use gibberish. It doesn't matter. It's going to clear it anyway when you're done. So you can clear your cells, and you just enter your x and y coordinates in C1 and C2 respectively. So 25 is my first x coordinate, 55 is my next one, 70 is my last one. Move over to the y's, or the second column, 30, 38, and 31. So this entire process of entering information is going to be exactly the same as what you did for linear regression. There's only one change, and that is instead of choosing linear regression, what do you think you're going to choose?
Not linear regression.
Quadratic regression. Okay, so again, what we do here is we can go to our calculate, F5, choose calculation type. It's not one of the first ones on the first screen, so you have to scroll down or hit the number 9, and that says quadratic regression, or quad reg. Okay, so what I did is I entered my information. And make sure you're entering it in the data matrix editor, not in a list. Okay, so you should have C1, C2 here as your cells or columns. And go to F5, the Calculate tab, and now under Calculation Type, you're going to scroll. You can either scroll down or up to get to number 9, Quadratic Regression. Okay, once you do that, what do we assign for our x-coordinate? Which column? C1. And then for our y-coordinate, C2. And remember, just like the other thing, store regression equation, it's probably a good idea to put that into the Y editor in case you need to use it again. And that's all you need to do. Once you have all that set, hit enter, okay, and you have your equation. Now, remember that ax plus b was the general form of the linear regression or linear equation. Ax squared plus bx plus c is the general form for your quadratic. So when you look at this, what you see here is our a is a negative number. Does that make sense that it would be negative? Why? What direction does our graph open? Down, so would you expect the leading coefficient to be negative? Yeah, so you have negative 0.016. So negative 0.016 x squared. That's our first term, or our first coefficient, our a value. Our b value is 1.57. So we can say plus 1.57x. Again, this fits our standard form of ax squared plus bx plus c. And then finally, our constant, our c value is 0.926 approximately. So plus 0.926. So here is our equation that models the fuel efficiency based on these readings. All right. Now, what did I say we need to find? If you wanted to estimate what is the ideal speed for this car to get the maximum fuel efficiency?
55.
Well, we don't know that yet. These are just readings. We used 55 because that's kind of what the federal guideline is. Okay. But we need to find the vertex. So how would we find the vertex of this graph?
Plug in the vertex thing.
Okay. So you could do negative b over 2a, right? But that's actually work for you. There's another way to approach it. Eddie? Okay. Or you can use the graph that we have, because have we entered this equation into our calculator? If you use store regression equation, then you did, right? You stored it as y1, you're in the y editor. And now, do we see where the vertex is here? No. And does it make sense that we wouldn't find the highest point when our x only goes up to 10? So what should we change our viewing window to? Go to window, which is green diamond F2. The x minimum doesn't matter, but what about x max? Let's go all the way to 120. Okay. The scale you can change if you want. It doesn't really matter. I mean, you can put it as 10 if you wanted to. The y minimum, not really going to matter. The y maximum, we want it to extend beyond 38, so let's go to 50, just to be safe. So if you set your viewing window so that you know you're going to view everything, we can now relook at our graph. Okay, we see it's going up and then it starts to come back down, which is what we expect. And so how can we find this point? Again, doing what we did with the last step. So we go F5, the math tab, and then, good, maximum. Choose the lower and upper bounds. So again, for my lower bound, I'm just going to hit 0 here to make it easy. My upper bound, I'm going to hit 120. Again, that puts it all the way over here. And then it'll give me my vertex. And so it says, according to these, 48 miles per hour is the ideal speed for maximum fuel efficiency. It gets you 38.75 miles to the gallon. Again, just these are random numbers, but you can actually, this is how they actually find these values and put those estimates on cars.